when we talk about points of intersection, what that's really saying is that when these two things, it could be a line and a parabola, it could be two lines, it could be two parabolas, it could be any two functions, when those two functions meet at the same point, so when they are equal to each other. So when you see point of intersection, I want you to write like when they are equal to each other. I want you to know like equal. Okay, when the two things are equal to each other, because that's when they're meeting. So if I have two lines right here, right, and I have y equals 3x plus 15 and y equals 3 minus 3x. So these two y's technically are the same. So we can set 3x plus 15 equal to 3 minus 3x. So now we only have x's, right? So we just substituted in one of these expressions for one of the y's, and so now we have only x's. So we're going to solve for x. So we're going to get all the x's on one side. So I like to undo subtraction because I think it's easier if everything's positive. So I'm going to move this 3x over by adding 3x to both sides. Right, and so negative 3x plus 3x gives me 0. If I'm down by 3 points and I score a 3-pointer, I'm now tied, right? So 0. So I have 6x plus 15 equals 3. Well, I'm not done, right? Because I need that 15 to move over. So I'm going to subtract 15 from both sides. So 3 minus 15 gives me a negative 12. So I have 6x equals negative 12. And now I need to get x completely alone. So to undo that 6, because the 6 is multiplying the x, I have to divide by 6. So I end up with x equals negative 12 over 6, which is just negative 2. But we're not done, right? Because it asks for the point of intersection. So this is the x coordinate for that point, but we need to find the y coordinate. So we can just plug this x value into either equation. So I am just going to choose the second one, just randomly, arbitrarily. It doesn't matter which one you plug it in, because they should both equal the same thing, right? Because if they're intersecting at that point, that means at that point they're both equal. They both share that point in common. Okay, so we have y equals 3 minus 3 times negative 2. Okay, so 3 times, or like negative 3 times negative 2 gives me a positive 6. So this turns into y equals 3 plus 6. And 3 plus 6 is just 9. So y equals 9. So my full point of intersection, if we write it in its coordinate form, is negative 2, comma 9, because we always write points as x, comma y.